All right, good morning. So today we are going to be learning how to multiply rational expressions. And so we call this a rational expression. We call this a rational expression. This operator means multiply. So how do you multiply? Well, when you multiply rational numbers, like when we had, say we had a half times 2/3. In elementary school, you learned you multiply numerators, 1 times 2, 2 times 3. So you multiply numerators, multiply denominators, and then you end up with a fraction that you reduce. 2 over 6 reduces to 1/3. So that is the process of multiplying, and we do the same thing for rational expressions. Okay, so here's an example. They worked out for you. Since that one's worked out for you, I'm going to go ahead and jump to example 2. There's a few ways to look at this. In their example, they took 5 times 16 got 80, 8 times 15 got 120. And then they just had a b cubed c cubed, c squared a squared b, all right here. And then they started reducing. Instead of multiplying the numbers together, I think it's better to just leave them separate. So for example, I would write this as 12, and then it's multiplication. So I'd put 12 times 27, and then I'd put the variables. So 12 times 27, we'll do x, y squared, m cubed, p. And then on bottom, I have 45 times 40. And then m, I'm going to go ahead and put my x's first, x cubed y, just to line them up. MP squared. Now from here, there's a couple ways to reduce this. You should know how to reduce numbers already. One way would be to just look at common factors. So I could break this up into what's called the prime factors. I'm trying to decide. So I can multiply this as 4 times 3. And that is 2 times 2. This one is 3 times 9. And then 3 times 3. You don't have to do it this way, but here's, this is just one way. Now this is 9 times 5, 3 times 3. 40 is 8 times 5, 4 times 2, 2 times 2. And all it does is it helps you find common factors. So for example, I see a 2 up here, and you cancel that out with the 2 down here. I see another 2. I see a 3. Let's see, I don't see any other. Oh, there's another 3. Remember, I don't look at 4 because it was broken up. And then I have 3 and 3. And I have 2 and 5. And I don't see any other 5s up there. So it looks like this part right here reduces to 9, 3 times 3, over 5 times 2, times 5, so 9 times 50, 9 over 50. So that's one way you could do it. I'm just going to confirm on my calculator. Nine over 50. Okay. All right. Next, if you think about the x's, this means 1x. This means 3x's. So 1 goes away, leaving x squared on bottom. For y's, I have 2 y's and 1 y. 1 y goes away, leaving 1 y on top. For m's, that's 3 m's and that's 1 m. So 1 goes away, leaving m squared on top. And then we have our p's. There's 1 p, 2 p's down here. 1 p goes away, leaving a p in the denominator. Now, what are the restricted values? M cannot be 0. P cannot be 0. X cannot be 0. Y cannot be 0. So my restricted values would be M can't equal 0. P can't equal 0. X can't equal 0. And Y can't equal 0. So that's one way you could do simplifying a number. For some kids, it might be easier to multiply this out and then just start simplifying. For example, I could have taken 12 times 27. You got 324. I could have taken 45 times 40. You got 1800. So I'm going to show you a different way to go from here to the 9 over 50. So you could just multiply those together. And then I noticed that they're both even, so I divide them both by 2. So 324 divided by 2 is 162. 1800 divided, I can do that in my head, that's 900. But then both of those are even, so I divide those by 2. And then I see that 9 goes in 81 and 450. So I divide them both by 9. And I get 9 over 50. So that's another way to reduce the fraction. Same thing, 9 over 50. All right, so they're relatively simple when there's no plus or minus signs because nothing's together. But as soon as we introduce the plus or minus sign, we know that x and the 5 go together. Okay, this x is separate. This x squared is separate. Here, x squared minus 2x minus 15 goes together. So when I look at this, first thing I would do is go ahead and factor what you can. So this part right here is the only part that can factor. And what you look for, this is a trinomial, 1, 2, 3, a is 1. I'm looking for two numbers that multiply to negative 15 but add to negative 2. And that would be negative 5 and 3. So this part here factors into x minus 5, x plus 3. So now when I put all this together, I get x minus 5 times x squared and then I have x over, and this part factors into this. From here, common factors, I have an x minus 5 here and here. Those go away. X plus 3, I don't have another X plus 3. But X squared, you could break that up into X and X. So you have one X that goes away. And that's what we're left with. We're left with, let's see, of the X squared, one X went away. So I'm left with one X all over, went away, divided out common factors, X plus 3. And remember, you cannot eliminate these X's because this is an X plus 3 and that's an X. Now, my restricted values, I would say X cannot be 0. And then what makes this 0 is when X is 5 and when X is negative 3. So I'd say the domain is all real numbers except for 0, 5, and negative 3. So really this skill is just can you factor. All right, on this one, a plus 1 is linear. There's nothing we can do to it. A plus 2 is linear. There's nothing else I can do to it. 3a plus 3. Let's see. 3a plus 3, that's not hard to factor. You can't factor it with an x, but it does have a GCF. This makes 3 as a GCF, leaving a plus 1. You divide both of these by 3, a 3 comes out. This part factors. A equals 1 multiplies to 10, but adds to 7. That's 5 and 2. So this part makes a plus 5, a plus 2. Now I put all that together, and I get a plus 5, a plus 2. Times 3 times a plus 1 all over a plus 1, a plus 2. So all I did was put all this on the top and then all this in the denominator and the denominator. Then I divide out common factors. I have an a plus 1 here and here. It's 1 for 1. And then I have an a plus 2 here and here. So everything in the denominator went away, except for there's always a 1 there. But you don't really worry about the 1 in the denominator, but you must worry about it in the numerator. So if everything cancels in the numerator, make sure you put it 1 over that. But here, when the denominator goes away, not a big deal. So our answer is a plus 5 times 3. It just looks better as 3 times a plus 5. And technically, that is the correct answer. If you wanted to, you could distribute that back in and get 3a plus 15. But both of these are the same thing. Now my restricted values. A cannot be negative 1. A cannot be negative 2. And remember, that's because negative 1 plus 1 is 0. You can't divide by 0. Negative 2 plus 2 is 0. You can't divide by 0. Let's do another one. B plus 3 is a linear factor. Nothing we could do. 4b minus 12. That has a GCF of 4. Leaving b minus 3. Here, what multiplies to 3 but adds to negative 4? multiplies to 3 and adds to -4 would be -3 and -1. Here, A is 1, 3 terms. What multiplies to -30 but adds to -7? See, 2 and 15 makes 30, but does not subtract the 7. 3 and 10. That would work, 3 and 10. So if I do -10 and +3, -10 times 3 is -30. -10 plus 3 is -7. So this makes b minus 10 b plus 3. All right, so let's see what we have here. If I put all this together, I get b plus 3. Notice I put it in parentheses to show that those two were together before I combine them. B plus 3, b minus 3, b minus 1. Here, 4, b minus 3, b minus 10, b plus 3. I divide out common factors. I see a b plus 3 here and here. I see a b minus 3 in numerator and denominator. And that's it. So I get my reduced fraction, which is b minus 1. You don't need parentheses anymore since that's all that's up there. You could put them if you want. And then a 4 and a b minus 10. And then what are my restricted values? So these are numbers that are not included in the domain x. Ooh, there is no x. Let's try again. B cannot be 3. Okay. B cannot be 10. B cannot be -3. And that's it. Okay, so for practice, I have some expressions I want you to multiply. Notice all of the operators are multiply, 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 multiply. Remember, you cannot cross off x squared with x squared because x squared goes with the minus 6x. So here's a whole page, operator multiplication. And I think you are ready. On problem number 29, it starts it off for you, and you're supposed to finish. I hope you remember how to factor this. I know it's been a while. So I'm just going to show you how they went from here to here, because it has been a while. No GCF, you take 2 times -3. That's -6. 2 times -3. Bring down the 5. What multiplies to -6 but adds to 5? That'd be -5 and -1. No. Close. 6 and -1. I almost messed up. 6 times -1 is -6. 6 plus -1 is 5. So then you put x plus 6, x minus 1. And then because of that 2, you divide them both by 2. And you either reduce or you slide. So 6 over 2 reduces to a 3. 1 over half doesn't reduce, so the 2 slides to the front. You get 2x minus 1. So that's how they went from this to this. I know it's been a while. And then don't forget, problems like x squared minus 16, those are difference of two squares. So you go a square, that's x and x. A square, that's 4 and 4. 4 times 4 is 16. And then you get x plus 4, x minus 4. So this one's not done. This one's not done. I just wanted to take a minute and remind you of a couple other factoring techniques that we have used. Other than that, that's all I have for today. Next time we will divide, and I hope you have a good day. All right, bye-bye.